On the current generation of civil transport aircraft, such as those manufactured by Boeing and Airbus, pilots fly the aircraft in one of three ways: manually via the flight controls, tactically via the flight control unit, and strategically via the multifunction control and display unit. Interactions between pilots and the aircraft are carried out using physical controls, buttons, knobs, switches and keypads, which are distributed around the cockpit, including on the glare shield, central pedestal and overhead panel. Touch Flight 2 is aimed to augment these conventional modes of interaction with newer interaction modes, specifically touchscreen gestures and voice commands, which are already established in many areas, such as smartphones, tablets and cars. The project was a collaboration between the Institute of Aerospace Technologies at the University of Malta and Quaero Limited, a Maltese aviation consultancy company. Professor David Zamit Manjon, Director of the Institute of Aerospace Technologies and Principal Investigator of Touch Flight 2, explains the idea behind the project.
The Touch Flight and Touch Flight 2 electronic pilot monitoring projects are two projects which we at the Institute of Aerospace Technologies at the University of Malta are conducting, and we are focusing on developing new and novel techniques of interaction between the pilot in the cockpit and the cockpit systems, the airplane itself. The importance of the human-machine interaction on board aircraft is becoming more and more significant today. The reason is because the industry is looking towards enhancing safety in flight, and of course modern aircraft are becoming more and more complex. And the human being, the pilot, remains what we call the Mark I human being, which is essentially evolving at a very slow pace compared to technology. And here we have the need, therefore, to come up with new concepts and new techniques to allow the pilot to be comfortably working and communicating with the aircraft systems in a way that he or she feels comfortable and correct.
Captain Alan Muscat, one of the directors of Quaero Limited, explains the role of Quaero within Touch Flight 2.
Quaero is an SME run by active airline pilots, several of whom are qualified type-rating instructors and examiners. Altogether, we bring over 65,000 hours of flying experience to the projects we work on. Apart from our flight experience, our pilots hold various degrees and postgraduate degrees in science and engineering, ranging from electrical engineering and computer science to chemistry and biology. This operational and academic background gives the company the unique ability of being able to bridge the gap between theoretical research and the practical operational side. Our part in the Touch Flight and Touch Flight 2 projects has been to bring this expertise into the requirements gathering, design, implementation and testing of the project. In this way, the human-machine interface has the pilot as the center of focus throughout its development.
The Touch Flight 2 project focused on three main aspects: touchscreen technology, direct voice input, and electronic pilot monitoring. The touchscreen interface concept proposed in Touch Flight 2 enables pilots to interact with avionics systems via a single touchscreen device located at a convenient position in front of each pilot. The interface consists of 5 main sections dedicated to tactical flight control, navigation, performance, systems, and radios. The direct voice input interface consists of 2 main modules: a speech recognition module and a command recognition module. The command recognition module processes the output of the speech recognition module in order to check whether it matches any of the predefined voice command templates. If a command is detected, it is read back to the user using synthetic speech and displayed on the touchscreen interface and sent to the appropriate avionics system to be executed. In Touch Flight 2, approximately 75 voice commands were defined for different functional areas, including tactical flight control, flight management, radios, aircraft controls. The phraseology of the voice commands was based on that used in standard operating procedures, SOPs, to maximize learnability and ease of use of the system. The Electronic Pilot Monitoring, EPM, is a function that replicates some of the tasks that are normally carried out by pilot monitoring during specific phases of flight, such as takeoff and go around. For instance, during takeoff, the EPM issues call-outs when the aircraft reaches particular speeds and when a positive rate of climb is detected. The following footage is from a full flight simulator, which shows how the Touch Flight 2 concept could be applied in an operational environment. Tactical flight control.
Set flight level 340.
Set flight level 340.
Flight management.
Direct Ponza.
Direct PNZ.
Radios.
Contact Luca radar.
Contact Luca radar.
Aircraft controls.
Flap 1.
Flap 1. Speed check. Flaps 1.
In order to validate the multimodal interface concept developed in Touch Flight 2, a series of evaluations were carried out with the participation of commercial airline pilots. Dr. Jason Gauci, an academic at the Institute of Aerospace Technologies and co-investigator of Touch Flight 2, explains how the evaluations were carried out.
The evaluations were carried out in two phases. The first phase of evaluations was carried out on a preliminary prototype of the multimodal interface, approximately halfway through the development phase of the project. These evaluations were carried out with the participation of 3 commercial airline pilots using a desktop simulation environment. Following these evaluations, the interface was developed further based on the critical feedback provided by the pilots. The second phase of evaluations was carried out on a mature version of the multimodal interface. For these evaluations, the interface was integrated in a realistic and immersive flight simulation environment and evaluated by 8 commercial airline pilots from Air Malta, with flying experience ranging from 5,000 to 9,000 hours. Each evaluation consisted of a complete flight, during which each pilot had the opportunity to use the various features of the interface and practice them in different flying conditions and weather conditions.
Mr. Kevin Thuma, a research engineer for the Institute of Aerospace Technologies, was one of the key developers of the flight simulator that was used for the final evaluations.
For the evaluations, we constructed a flight simulation environment which was interfaced to the proposed touchscreen technology and a voice recognition system. My role was to develop this environment. The simulator is based on a representative A320 model and includes replica hardware such as the central pedestal, FCU, primary flight controls and displays. The simulator has the facility to simulate various weather conditions and other variables. This setup allowed us to evaluate the system using various realistic scenarios.
The Touch Flight 2 project successfully demonstrated the benefits of introducing touchscreen gestures, voice commands and electronic pilot monitoring to the flight deck of commercial aircraft. The research team behind the project believes that it is no longer a question of if, but when these technologies will find their way to the flight deck of civil transport aircraft. In the future, the team plans to investigate other interaction technologies, such as those based on augmented and virtual reality, in an effort to make the future flight decks safer and more efficient.